In this chapter we're going to talk about installation of VPVision. So it's about mechanical installation, how to connect sensors, remote I/O modules, and at the end of the chapter we'll also talk about 3G and 4G wireless connections. Before we continue, there are two important warnings. First of all, VPVision is professional equipment which should be installed by certified professionals. Secondly, VPVision is sensitive for ambient temperature. It contains an industrial PC which has a limited temperature range up to 40 degrees ambient. So make sure when you're going to install it that the environment temperature is not exceeding that limit. Now let's unbox the VPVision. When you open the cardboard box you will find inside a metal cabinet and also this key. This key is very important to unlock the cabinet and to open it. And after you've done that, you can take out the foam which we put in there for protecting the equipment during transport. Once you have removed the foam, check if every part on the DIN rail inside is still fixed at the right position. You can do this by comparing it to the drawing and pictures in the user manual. And if something became loose, please mount it back on the DIN rail. Sometimes this happens due to customs inspections or due to very rough treatment of the transport company. After you've done that, we can continue to the next step. Let's take a closer look into the VPVision components. First of all, on the far left, you will see the 24-volt supply terminals for the analog sensors. Besides that, you will find the I/O module, which converts 4-20 to Ethernet, which is connected to the VPVision main PC. Then you will find the RS-485 terminals for the flow scope sensors or other RS-485 Modbus sensors. And below that you will find also an earth rail. This earth rail is used to connect all the shielding from the cables going out of VPVision. It's very important always to pay close attention to proper shielding of the signals. Then you will find the VPVision main PC, and just beside that, by the way, you will find also two little fuses. One fuse is used for the 485 circuit and the other fuse is used for the analog sensors to protect them from too much current in case you make a mistake during installation, which you probably don't do because you're a very good certified electric professional. Then the VPVision main PC, you will see that it's an industrial PC with 4 Ethernet ports on it. You will see some serial ports and there are some LEDs which will show you the status of transmit and receive of signals, for example. Besides the VPVision you see the main power supply, which is a 24-volt power supply with 2 outputs. And on the far right you will find a main circuit breaker which you can flip and we strongly recommend during installation to keep it off to protect you or others from any electrocution. So before we continue with mechanical installation, I have a few more warnings for you. I cannot stress enough that VPVision is professional equipment which should be installed by certified trained professionals. Secondly, VPVision contains an industrial PC which has a limited environmental temperature range. So it's very important to check and double check if the environmental temperature of the cabinet is not exceeding 40 degrees Celsius. Please also check the specifications. You will find temperature range and other specifications also in imperial units in Fahrenheit. Then when we're going to install VPVision, check if the environment is safe for this kind of equipment. Think about vibration. VPVision should not be exposed to excessive vibration. Think also about potential water leakage. Make sure it's installed in an environment that stays dry, where there's no chance of leakage, for example, of lines running above the VPVision cabinet. Third, it's also important to install it on a smooth, straight wall where it's easy accessible. So to wrap it all up, it should be basically installed in a nice, clean, safe place where you can access it in an easy way. Now let's continue with installing this cabinet to the wall. Now let's take first a closer look. If you look at the back of this VPVision main cabinet, you will find 4 mounting holes and those holes are used to mount it basically to the wall. And in these holes there are 4 plastic plugs, which you have to remove before you can actually install it. After you have mounted it to the wall, it's time to connect the mains power supply cable. You will see that there is one bigger gland in the VPVision main cabinet, and that's intended for the main power. So you can push the cable through that gland and then connect it to the main circuit breaker. The power cable will also contain a ground wire, and we always recommend to measure the voltage difference between that ground wire and a nearby object which is made from metal, for example compressed air line, because you don't want to have large voltage difference between the ground and the cabinet, because it might indicate that the ground is polluted. So after you've checked that, you can mount also the ground wire to the ground terminal, and we're good to go for the next step, which will be the installation of the sensors and remote I/O modules. VPVision offers flexible and scalable I/O, so you can basically connect any sensor to VPVision and visualize it on the screen. We have 4 main types. First of all, inside the VPVision cabinet you will find a direct RS-485 Modbus input, so you can connect Modbus sensors directly to that. Secondly, in the VPVision cabinet there's also a 4 to 20 mA input module with 8 channels, which you can use for 4 to 20 based sensors like pressure sensors, temperature sensors. The third option is a remote I/O module, and there are various types. There could be Modbus to Ethernet converter. It can be an analog to Ethernet converter, again with analog 4 to 20 based inputs, or it can be a combined converter, so you have analog and Modbus in the same converter type. And the fourth option is that you have a sensor with a direct Ethernet output. It can be a flow scope M, for example, or it can be a kW meter with an Ethernet interface. So let's take a closer look into RS-485 connection of VPVision. If you open the cabinet, you will find a pre-wired screw terminal that provides power and the A and B signals for the RS-485 bus. That screw terminal is connected to COM port number 3 of VPVision. You will see that on the PC there are actually 4 ports, so if you want to expand later with additional Modbus daisy chains, you can do that by using the other COM ports available, but the standard port you're using will be COM port number 3. So when installing the Modbus network, it's important to be aware of the voltage loss, the voltage drop over the lines. So we recommend to keep the distances between the sensors as short as possible, and to remove also any excess cable and not keep big coils hanging there from the junction box to the sensor. Another thing is the voltage drop. You can check in the junction box, because there is an LED that will show when the voltage for the sensor is too low. Here you see an example of a Modbus network and how it can be documented after you have done the work, or if you want to subcontract the installation work to someone else. So you can document it in this way, so everybody knows what to do and how to install the sensors. Please be aware that in Modbus networks, and especially with using the flow scope products, you can only use a limited amount of sensors in a daisy chain. And this will be 8 sensors, and that's because of power limitations and because of the data traffic on the bus. Now if you want to learn more about Modbus, check the other chapters with more in-depth information, and also familiarize yourself with the Modbus protocol in general. It's a great way to connect sensors, but it also has some tips and tricks which you really need to be aware of to get a proper installation. Now the next thing, if you are going to start to install a daisy chain, is that you need to have junction boxes. For each sensor there will be a junction box, and you want to keep the distances between the junction boxes as small as possible, because distance means voltage drop. The other thing which is important is to have proper shielding on your Modbus cable, and also to use, of course, the right type of cable for your Modbus network. And the shielding is connected on one side of the bus, And in between the junction boxes you have to be sure that all the shielding is interconnected, so it creates one tight shielded line. Besides the Modbus input RS-45, you will find also the analog input module inside the VPVision cabinet. This module has 8 analog inputs. By default, the inputs are set into 4 to 20 mode. That means they can measure 4 to 20 milliamp based signals. If desired, you can open the unit and there is a little dip switch inside per channel where you can set the channel to 0 to 10 volt mode. If you want to know more about that, please refer to the user manual of the analog input module. Now, if you connect an analog sensor to the module, there are different analog sensors in 4 to 20. It could be a two-wire sensor, it could be a 3-wire or a 4-wire sensor. And we have some schematics in the VP Academy where you can see more details about that. What is very important to keep into mind is that you have to get the polarity right. That means that everything has to be in series in the 4 to 20 loop, and that the polarity of the analog module should correspond with the direction of the current output. If you reverse polarity, you won't damage the unit, but you will probably see an odd value, or you will see 0 milliamps flowing because it's protected against reverse polarity. Now let's take a closer look into the remote I/O modules. There are various types of modules. For example, there's an analog input module with 8 analog inputs, similar to the unit which you can find in the VPVision main cabinet. There is an RS-45 to Ethernet converter box, and there's also a combination that you have analog inputs and RS-45 in one remote I/O module, together with the power supply and the circuit breaker. Here you will see some schematics of those different boxes and how you wire them properly. And for more specific information about how to configure the boxes, I refer to the other video about how to set IP addresses of these remote I/O devices. Now let's take a closer look into Ethernet converters from remote I/O modules. There can be a situation where you have, for example, an analog I/O module, the same as in the main cabinet, but then on a remote location in a remote I/O cabinet. There can also be an RS-45 to Ethernet converter mounted in a remote I/O module, or it could be a combination. The way of connecting the sensors to those modules is the same. They're all pre-wired, so you will again find 8 analog inputs, for example, in an analog converter, or you will find a Modbus RS-45 terminal in a RS-45 to Ethernet converter, or you will find a combination of those two, together with a power supply and also a circuit breaker to turn on and off the power. Now let's take a closer look into Modbus TCP based sensors. You can connect them directly to VPVision through the company Ethernet network, or to a specific LAN port if you like. The only thing you need to do is to assign them with a proper IP address and the other network settings as provided by your IT department and documented in your configuration sheet, and then you should be good to go to add them in the back end of VPVision. When you want to access VPVision from remote, you need a VPN connection, because that's the only way to have a secure and safe way to connect to VPVision and to make sure that no other people that are not allowed on the system will accidentally or on purpose log in and maybe steal your data. VP Instruments provides a very convenient VPN connection box, which basically is connected in between VPVision and the company network. And it also provides cellular connection, so you can use an air card, a 3G, 4G data card to connect the VPVision to a cellular network. This will take care of all security measures, so it will block the ports that cannot be used, it will be password protected, and it sets up a secure VPN connection. And another thing is you can basically combine all kinds of VPVision systems. For example, if you supervise multiple sites in one convenient dashboard using the cloud.vpinstruments.com website. In that way you have one place where you can overview all systems, configure them, and also you have a secure way of getting out the reports from the VPVision systems into your mailbox by email.